We'll understand some properties before we start our next exercise. So here some of the properties of definite integration. Property 1. Property number 1, it says that integration a to b f of x dx can be written in another variable as a to b f of t dt and f of y dy and f of p f dp, whichever variable you want. You can replace that variable. Property 2, integration a to b f of x dx can also be written as minus integration b to a f of x dx. Means you can change the upper limit and lower limit here. You can interchange them. You have to take minus outside the integration. Property 3, integration a to b f of x dx can be written as a to c f of x dx plus c to b f of x dx if we have an intermediate value between a and b. Property 4, f integration a to b f of x dx can be written as integration a to b f of a plus b minus x dx. Right. So this x can be replaced as a plus b minus x. Property 5, integration 0 to a f of x dx can be written as 0 to a f of a minus x dx. This property 5 is derived from property 4 only. If I take the value of a as 0 and b as a in property 4, then I will get my property 5. Property 6, integration 0 to 2a f of x dx can be written as 0 to a f of x dx plus 0 to a f of 2a minus x dx. Right. Property 7 is derived from property 6 only. Property 7, it is stating that 0 to 2a f of x dx can be written as 2 times 0 to a f of x dx if f of 2a minus x is f of x only, and the same can be written as 0 if f of 2a minus x is minus f of x. So if you get the value of f of 2a minus x as f of x only, then you can write as 0 to 2a integration f of x dx as 2 times 0 to a f of x dx. And if you get f of 2a minus x as minus f of x, then the integration will be 0. Property 8, minus a to a f of x dx can be written as 2 times 0 to a f of x dx if you get f of minus x as f of x only, that is if your function is even, and minus a to a f of x dx, the value of this integration is 0 if your function is odd, that is f of minus x is minus f of x. This is the definition of odd and even functions. So if your function is even, that is f of minus x is f of x, then you can take this integration minus a to a f of x dx as 2 times 0 to a f of x dx. And if your function is odd, then the integration of this will be 0. So these are the 8 properties that we are going to apply in our next exercise. So I want you to just go through these properties before we start our exercise. Let's start with exercise 7.11. Question 1. Here I will take this as I 0 to pi by 2 cos square x dx. Give this as 1, we will use it. Now applying property 5. I can replace this x as a minus x, that is here my value of a is pi by 2, so I can replace this x as pi by 2 minus x whole square dx, which will be sine square x dx. Give this as 2. Now adding equation 1 and 2. We will add right hand side and left hand side. So I plus I will give me 2i 0 to pi by 2 cos square x dx plus integration 0 to pi by 2 sine square x dx. Yeah, I can take this integration common as the limit of both of them is same only, so 0 to pi by 2 cos square x dx, that is cos square x plus sine square x dx. I can write this, but you can see that this is your identity, sine square x plus cos square x will be 1. So integration dx is just x 0 to pi by 2. So pi by 2 minus 0 will give me pi by 2, but this is the value of 2i. The value of I is pi by 4. Right. We want the value of I only. Again, I will take this as I 0 to pi by 2 root sine x upon root sine x plus root cos x dx. So using property 5, I can replace this x as a minus x, give this equation as 1. So I will replace this is root sine pi by 2 minus x dx upon root sine pi by 2 minus x plus root cos pi by 2 minus x. Now the function will change, so it will be 0 to pi by 2 root cos x dx upon, this will be root cos x plus sin x, but I will write this as root sin x plus cos x, as addition is commutative. I can write a plus b as b plus a. Give this equation as 2, adding equation 1 and equation 2. I plus I will give me 2i, as the integration of both of them is same. I can write this as root cos x upon root sin x plus root cos x plus root sin x upon root sin x plus root cos x whole dx. As you can see that denominator is same, I can write this as root sin x plus root cos x. So these two terms are same, it will get cancelled. And I will have integration 0 to pi by 2 dx. Integration dx is just x. And keeping the limits, I will have pi by 2 minus 0, that is pi by 2. Therefore, the value of I is pi by 4. Question 3. I will take this as I 0 to pi by 2 sine raised to 3 by 2x dx upon sine raised to 3 by 2x plus cos raised to 3 by 2x. Give this as 1 using property phi. I can replace x by pi by 2 minus x. So sine pi by 2 minus x whole raised to 3 by 2 upon sine pi by 2 minus x raised to 3 by 2 plus cos pi by 2 minus x whole raised to 3 by 2. And you know that pi by 2 will change the function, so it will be cos raised to 3 by 2x upon this will be cos raised to 3 by 2x, and this will be sin raised to 3 by 2x dx. Use this as 2. Adding 1 and 2, I will have I plus I 2i 0 to pi by 2. I am taking just a common integration, as both of them is having the same limits. Sin raised to 3 by 2x upon sin raised to 3 by 2x plus cos raised to 3 by 2x plus cos raised to 3 by 2x upon sin raised to 3 by 2x plus cos raised to 3 by 2x whole dx. As their denominator is the same, I can take LCM of sin raised to 3 by 2x plus cos raised to 3 by 2x. I will get sin raised to 3 by 2x plus cos raised to 3 by 2x dx. As both of these terms is same, will cancel it out, and I will have integration dx, whose answer is just x. Will keep upper limit first, and then lower limit is 0. So value of I is pi by 4. Question 4. I is equal to integration 0 to pi by 2 cos raised to 5x dx upon cos raised to 5x plus sin raised to 5x. Right. Use this as equation. We will use it using property phi. I can replace x by pi by 2 minus x. So cos pi by 2 minus x whole square, sorry, raised to 5 not square. Cos pi by 2 minus x whole raised to 5 plus sin pi by 2 minus x whole raised to 5 dx. So I is equal to 0 to pi by 2. This will be sin raised to 5x upon this will be cos raised to 5x plus this cos will be sin. So I am writing it after sin raised to 5x. As you know that addition is commutative, I am just flipping the terms. Give this as equation 2, and we'll add equation 1 and equation 2. So I plus I will give me 2i. I am just taking this integration 0 to pi by 2 common. Cos raised to phi x upon cos raised to phi x plus sin raised to phi x plus sin raised to phi x upon cos raised to phi x plus sin raised to phi x whole dx. I can take LCM as the denominator is same, so I can write this as cos raised to phi x plus sin raised to phi x dx. As you can see that the numerator and denominator is same, I can cut them out and I will left with just dx. Integration dx is x, limit is 0 to pi by 2. So keeping the upper limit will give me pi by 2 minus lower limit to 0 will be 0. So my final answer is pi by 2. Question 5. Uh, Integration minus phi to phi mod x plus 2 dx. You know that mod x plus 2 can be written as x plus 2 if x is greater than or equal to minus 2 and minus x plus 2 if x is less than minus 2. So I will split this integration from minus phi to minus 2 mod x plus 2 dx plus integration minus 2 to phi mod x plus 2 dx. As you can see that minus 5 to minus 2 will have mod x plus 2 negative as the range is less than minus 2. Minus 5 to minus 2 is less than minus 2. I can write this mod as minus x plus 2 dx, whereas from minus 2 to 5 this range is greater than minus 2. I can write this as x plus 2 dx. Now giving individual integration, I will have minus x raised to 1 plus 1 upon 1 plus 1 and this would be minus 2x minus 5 to minus 2. Right, I have opened this bracket, so it will be minus x minus 2. Integration of minus x is minus x square by 2, whereas integration of minus 2 is minus 2x. The same way integration of x is x square by 2 and the integration of 2 is 2x minus 2 to 5. Keeping the upper limits and lower limits, I will have minus into minus 2 square is 4 by 2 minus minus 2 to the 4 minus bracket keeping minus 5 will give me 25 upon 2 minus minus plus 10, right, bracket over plus keeping 5 will give me 25 by 2 plus 10 minus keeping minus 2 square is 4 and minus 2 to the 4, right. So this will be minus 2 plus 4 minus minus plus 25 by 2 minus 10 plus 25 by 2 plus 10 minus 2 minus minus plus 4. So this minus 10 plus 10 will get cancelled out. Uh, this will be 4 minus 2 will be 2, 4 minus 2, 4 minus 2 will be 2, 2 plus 2 it will be 4 plus this will be 50 by 2, that is 25. So final answer is 29.